What if I told you that this little machine is the perfect Proxmox virtualization server? And what if I told you I crammed an Intel Core i5, 64 gigs of RAM, a 1 terabyte NVMe SSD, another 1 terabyte SSD, all in this tiny little box that's dead silent without any fans? And what if I told you it can run Proxmox virtual server, host a pfSense router, run TrueNAS with a terabyte of storage, run Ubuntu Server with Portainer running a few Docker containers, run Windows 10 or 11, and run an Ubuntu desktop and pass through all of the hardware so I can use this server as a desktop, all while running a Plex server and doing hardware transcoding with 3 4K streams? No way. No way. Yeah, I thought you'd say that. You might have heard of Protectli before. They're known for making really great appliances for many open source software distributions. And most people think of Protectli Devices as the perfect device for a router like pfSense. And that makes sense considering that the device comes with anywhere from 2 to 6 network ports. But their devices can be used to run almost any software imaginable, from Linux to Windows to a dedicated firewall, to even a virtualization host or a hypervisor. That's possible because of the hardware that's inside of these devices. Protectli sent me a VP4650 to help with some of my home lab projects, and this device is a beast. This is the VP4650 and comes with an Intel Core i5 quad-core CPU with hyperthreading that is rated at 1.6 GHz and can turbo boost up to 4.2 GHz. The nice thing about this CPU is that it supports VTX for virtualization and VTD for IOMMU, so I can pass through devices to the guest. And because it's an Intel processor, it comes with AES NI support, which is super nice for encryption and decryption for VPN or TLS. It supports up to 64 gigs of RAM, which is plenty for what I'll be using it for, but you can scale back down if you need, all the way down to 4 gigabytes. It comes with 6 Intel 2.5 gigabit NIC ports, giving you enough throughput for most of your networking needs. It also ships with a 16 gigabyte eMMC module on the board and many options for storage. Also, because this machine has an NVMe slot and a SATA port, you can mix and match your storage to fit your needs. I opted for a 1 terabyte Samsung M2 NVMe and a 1 terabyte Evo drive. You also get the choice of adding Wi-Fi modules and a 4G LTE modem. However, I decided not to on this device because they also sent a lower powered BP2420 that has 4 network ports along with a Wi-Fi and LTE modules to help me build the ultimate router, which you'll be seeing in a future video. If you notice from everything I listed, you didn't hear anything about fans. That's not something that's obvious from the specs on paper, but taking one look at this device and you can see a huge heatsink that passively cools the entire device. It definitely looks like a grill, but I promise you can't cook anything on here. As far as connectivity goes, you have plenty of options for connecting devices, from USB 2.0, 3.0, USB-C, to HDMI, to DisplayPort, and even a micro SD port for console access. One thing that I like about these devices is that you have your choice in firmware to use. You can use a standard AMI BIOS that works great, or you can try out the CoreBoot BIOS, which is a bare bones open source BIOS that lets you customize some pretty cool features. For instance, if you flash one of their devices with CoreBoot, you can boot to the network and download and install many different operating systems from the network or even from the internet. This is a neat feature that I welcome, and it saves you the hassle of loading up that Ventoy USB disk with yet another ISO. I did, however, opt for AMI BIOS because I did have a few issues with CoreBoot related to using my Ventoy USB disk. But that's the nice thing about the BIOS being open source. It will get better and more secure over time with more eyes looking at it and more engineers contributing to it. So, what did I do with all this hardware? The better question is, what didn't I do? I knew that I wanted my build to be completely silent and I wanted my hypervisor to be Proxmox. So the first decision I had to make was where I was going to install Proxmox. Remember, I had the choice between the NVMe drive, the SATA drive, and the eMMC module. Turns out the eMMC module isn't really an option because Proxmox won't let you install it there without some hacks. And I didn't want to hack this device, so I decided to install it on the NVMe drive and use the rest of the partition for virtual machines. Now, typically I would have installed the OS on the slower drive and saved the NVMe for VMs, but I have other plans for that. Installing Proxmox was straightforward, just like any other Proxmox installation. After it was installed, I then configured IOMMU so I could pass devices through to the guest machine and everything else I have on my first 11 things on Proxmox video. After that was all set, it was now time to install some virtual machines. I knew that I wanted to install a router on this machine. This will give me the flexibility to run a network firewall for all of these devices and give me the option to protect any device I use when I travel, but more on that later. So I installed pfSense and passed through 2 of the NICs, from the host down to the guest. This first NIC is the WAN port, so an upstream provider like an ISP or even some network I don't trust. And then the other port is for LAN if I do want to connect all of these devices to my local network. Passing these through and configuring them was pretty simple, and if I forget which port is which, they even included some stickers for me to label the ports. I also added another network port that's used as a network bridge in case I want these VMs to use an internal network that doesn't communicate with my local network. Now that the router was done, I wanted to configure a NAS on the device. This NAS could be any open source NAS, but I chose to go with TrueNAS Scale. I went with TrueNAS Scale because, well, it's TrueNAS. And I wanted Scale because I wanted a Linux-based operating system that plays better with Proxmox. After installing TrueNAS, I then created a 1 terabyte drive in Proxmox and then assigned it to TrueNAS so that I can have 1 terabyte of storage on my NAS. Now, I know it's not ZFS and I know I don't have redundant drives. So if you do the same thing, you'll want to be sure that you have your data backed up to another machine. Once I had TrueNAS up and running, I could set up NFS and Samba shares just like I would normally on a physical install of a NAS. I can also pass through one of the NICs to my NAS so that it can have a dedicated 2.5 gigabit NIC if I like. So router and NAS up and running. Awesome. Next up, I needed to run some containers. Yes, I know I can use TrueNAS to do this, but I wanted to go with my preferred combination of Ubuntu Server, Docker, and Portainer. Having a dedicated Ubuntu server running Portainer gives me a great UI and so many possibilities. After installing and configuring it, I then created a few containers. This is a perfect host now to run all of my self-hosted services. After getting the foundation all set up, I then had my choice of desktop OSs. I could choose between Windows and Ubuntu Desktop. Then I looked at how much disk space I had and how much RAM I had left over, and I thought to myself, why not both? I first installed Windows 11 and configured it. No problems there. But after installing Windows, I wanted to pass through the GPU on the device to the virtual machine, along with the sound card and USB devices, so I could use this as an all-in-one server and desktop too. After messing with this for hours, I could not get this single Intel GPU to display anything on the screen, even though it was definitely passed through to the guest machine and I could see it installed over remote desktop. So I thought maybe this was Windows 11, so then I created a Windows 10 machine and it did the same thing. So passing through the only GPU on the device was not looking good so far. So I decided to try again, but with Ubuntu Desktop, and sure enough, it worked. I was able to pass through the integrated GPU from the host down to the guest and use this machine as a desktop. Now, I will be the first to admit that this isn't winning any performance awards, but I was able to do most tasks that I would expect to do on, say, a laptop. I installed VS Code, I customized the desktop, watched some YouTube, and even passed through the thermal subsystem so I could monitor the temperature of the host. This was pretty cool. After I had this working, I decided to install Plex on this machine so that I could see if I could get QuickSync working. So QuickSync is a technology and a dedicated chip on most modern Intel processors that lets you offload the decoding and encoding of video from the processor down to this chip. So this technology is very similar to NVENC on NVIDIA and AMF on AMD, but the idea is that you give this work to another part of the processor instead of pegging all of your cores on your CPU. Plex can take advantage of this if you have a Plex pass, and I do. So I wanted to see if I could get it working. And that's where I started to run into troubles again. I thought that since I had passed through the GPU on the Ubuntu machine, that Plex would just see QuickSync and use it. No matter what I tried, I could not get Plex to do hardware transcoding. I even tried Docker containers, which supposedly should work if the hardware is mapped properly. However, I couldn't get that to work either. Then I decided to try my Windows VM because I could see the Intel GPU when using remote desktop, so I had some hope. Sure enough, when I installed Plex and started streaming a video, the hardware-enabled transcoding kicked in and the CPU barely budged. I was able to transcode 3 4K streams down to 1080p, 720p, and even 480p, no problem. This was awesome and puzzling at the same time. The Windows machine could see the GPU and take advantage of QuickSync, but I couldn't output the display from the HDMI or DisplayPort. And the Ubuntu machine could output to the monitor over HDMI, but I couldn't use QuickSync. Judging by the fact that I was able to cover both use cases with different operating systems, told me that this was probably something related to software and not hardware, so I chalked this up as a bug or a software issue that may be fixed someday. Probably Proxmox. You might think that running 4 virtual machines on this device would draw a lot of power and generate a lot of heat. Well, I thought the same thing until I pulled out my kilowatt and decided to measure it. This Protectli machine running 4 virtual machines, the host itself, with all of these devices plugged in, pulled in anywhere from 20 to 30 watts, which I think is pretty good considering I have all of this functionality in one device. And if I wanted to save some power, I could power any one of these virtual machines down when not using them and even unplug the devices. As far as heat goes, well, do you hear that fan? That's right. No fan equals no noise, but it also means it's going to heat up the fins quite a bit. As you saw earlier, the thermals were around 56 degrees Celsius on that die, and it's actually much cooler on the heatsink fins, so you definitely can't cook anything on it. As you saw, I was able to create quite a few virtual machines and spin up an absolutely quiet hypervisor and then use it as a desktop, which goes to show just how flexible these devices are. If you go with one of these devices, you're getting a blank slate where you can create and build anything you want, from a full-fledged server with virtual machines to a small dedicated development environment. Now, it wouldn't be fair if I didn't mention some of the beefs I have with it too. Remember that eMMC drive that I mentioned? Well, if you're planning on using it with Proxmox, it's pretty much useless. Proxmox can't be installed on those types of devices, and even if I could, it's only 16 gigabytes. I'd love to see another option other than eMMC modules or even a space for another solid state. The other thing that some have mentioned is the price. These devices are priced a little more expensive than some of the other small form factor devices out there. So I wish the price would come down just a little bit. However, these devices are purpose-built. They have lots of customization options and connectivity options. They're industrial quality and allow you to swap out the firmware with CoreBoot at any time. And if you like those options, that might just be enough for you to justify the premium cost. Because I think these devices are premium devices. Well, I learned a lot about running Proxmox on Protectli devices, running Proxmox as a desktop, and I hope you learned something too. And remember, if you found anything in this video helpful, don't forget to like and subscribe. Thanks for watching.